Today's lesson is on inverse trigonometric functions. So up until now, if I were to ask you, what is the sine of pi over 6? You would tell me the sine of pi over 6 is 1/2. And we can see that on our unit circle, where I have the square root of 3 over 2, 1/2, and then here's my angle of pi over 6. But what if I asked you, what angle has the sine of 1/2? What would you tell me? Well, it could be a little confusing because not only does pi over 6 have a sine of 1/2, we also have the angle 5 pi over 6 also has a sine of 1/2. So tell me, which one is it? Is it pi over 6 or is it 5 pi over 6? Well, there's no way to really know because it could be either one. So when we're doing these inverse trigonometric functions, what do we have to do to make sure that you have a unique value? What we do is we restrict the range of the function. So if I told you that when I ask you that same question, it could only be on this part of the unit circle, and I said to you now, what angle has a sine of 1/2, you would look at this part that I've restricted here, and you would tell me, oh, it's pi over 6, because this part over here does not exist in our definition. So that part goes away, and we're only left with pi over 6. And by doing this, I can actually ask that question of any sine. Okay, if I ask you, what is the angle for the sine value of the square root of 2 over 2, you could look at this and immediately say, okay, well, it has to be here. It has to be pi over 4. Again, there's no ambiguity here. It can only be one value based on the fact that we restricted our values to only a certain part of the unit circle. And that is how inverse trigonometric functions work. In the case of the sine function, we have restricted the domain. So the domain can be between -1 and 1, but the range can only be between negative pi over 2, pi over 2. And by restricting that range, we have unique values for the angle when we're asked what the angle is for a specific sine. So when I graph that on a sine wave, notice it's only a very small piece of that sine wave that is actually our inverse function and the values of which our inverse function can reside. So in this case, notice it's only this little piece of the sine wave is where the inverse function resides. All this other stuff is not even here. That's all it is. It's this little sliver. So inverse sine function would be y equals the inverse sine of x. Now, of course, in math, we have to have multiple names for the same thing. And you might see it also like this, y equals arc sine of x. So those are two different words, those are two different ways to say it that mean the same thing. So let's go ahead and try this again. Here's our table, and these are the tables in our unit circle, or in this case, the right half of our unit circle. So notice our x is -1, and what angle has a sine of -1? Well, that's going to be
pi over 2. What
angle has a sine of 1? Well, that's going to be pi over 2. So as you can see, our x value is simply the sine of y, which is our angle. And then here's a graphical representation of our key points that are on that right half of the unit circle. So again, notice our y equals the arc sine of x, and when x is 1/2, for example, the y is going to be the arc sine of x, which is going to be pi over 6. So let's go ahead and look at our inverse cosine function. So again, if I ask you what angle has a cos 1/2, Well, if it has a cosine of 1/2, it's going to have a sine of the square root of 3 over 2, and that's this angle. But also I can go down here and notice this also has a cos 1/2. The sine is negative the square root of 3 over 2. So in this case, again, we have two possible values. Well, what did we learn from our sine function? We learned that we have to restrict the values that it can possibly be. So what I'm going to do is I'm going to say we're going to restrict that value for the top half of our unit circle. So this bottom half, in terms of the function, doesn't even exist. We're now left with, if I said to you, what angle has a cosine of 1/2, this goes away because it is not part of our range and domain. So if we look at the graph of this, notice here is our little sliver here, and once again, our domain is going to be between -1 and 1, and our range is between 0 and pi. So as you can see, it's the top half of this circle. So how we represent the inverse cosine function is it can be either y equals the inverse cosine, using our little -1 up top there, of x. It's also the arc cosine, abbreviated like this, and those are both the same thing. So graphically, what we do on these is we kind of tip them over and vertically translate them so it looks much like the actual function. So let's go ahead and look at this example here. So if I have, in the case of pi over 4 as my x, the inverse cosine function is going to be the square root of 2 over 2. And of course, that's because I can go back the other way. The cosine of pi over equals the square root of 2 over 2, or the inverse cosine of the square root of 2 over 2 equals pi over 4. And again, we get pi over 4 because we're restricting the specific angles that can be. We can also show it like this. The arc cos of the square root of 2 over 2 equals pi over 4. We have a similar thing for the tangent function, and in this case, if we look at it, the interval where we restrict the angle, again, it's very, very similar, and it's going to be between -pi over 2 and pi over 2. And again, we use the same logic, where if I ask you, what is the tangent of some value, you're going to give me the angle. So again, we can show it as either y equals the inverse tangent of x, or we can show it as y equals the arctan of x. So it's very much the same thing. So again, in showing our example, if the tangent of pi over 4 equals 1, then the inverse tangent of 1 equals pi over 4. And so again, what we're doing is we're restricting our tangent function on the unit circle to this half of the unit circle here. That way we can only get this angle for my tangent of 1. So again, in summary, this is our domain, these are our ranges, and let's go ahead and work some examples. So, what is the angle that's associated with the arcsine of -1/2? What angle has a value that has a sine of -1/2? So that's going to be -pi over 6. Again, why is it -pi over 6? Because we see that our range has to run between -pi over 2 and pi over 2. So we don't use the full unit circle. In order to do the right half of that unit circle, we have to use positive and negative angle measures. What is the inverse sine of the square root of 3 over 2? Well, the only angle that has a sine of the square root of 3 over 2 within this restriction is going to be pi over 3. How about this one? This is kind of a trick question. What is the inverse sine of what angle has a sine of 2? Well, we know that sines can only go between -1 and 1. Those are the values of sines. So what we would say is that this is undefined. Another way to look at this is the sine of x equals 2, which we know can't be the case. Let's try a second example with cosine and tangent. Value has a cosine of the square root of 2 over 2. Again, that's going to be pi over 4, as our restriction is that the angle has to be between 0 and pi. How about what angle has a cosine of -1? Again, we can say that that's going to be pi. What has an arctan of 0? Again, very similar. That's going to be 0. And what has a tangent of -1? Well, again, tangent goes between negative pi over 2 and pi over 2, so that must be negative pi over 4. Now you might question, why can't it be 3 pi over 4? Well, it can't be 3 pi over 4 because that is outside of this range. So we also have these functions built into our calculators. And what you'll see, for example, on a TI-84 is if you look at your TI-84, you'll see the sine function, and then right above it, you'll see the inverse sine function. On the older calculators, you'll see it as arc sine. On the newer ones, you'll see it more like this, but they're both the same thing and they do the same thing. So before we get into doing some problems in this section, I want to briefly go over how to use the inverse trigonometric functions on your TI-84 calculator. So first thing we want to do is check and make sure that you're in the correct units depending on the problem that you're doing. So what you want to do is you want to go into mode and you want to arrow down and you see here radians and then you see degrees. So depending on what you want to do and what units you want to go into, you choose that one. So let's go ahead and choose degrees here. So notice the cursor is blinking over degree. I'm going to go ahead and press enter. And now you can see my calculator is in degrees. So let's go ahead and try some inverse trig functions. So the inverse trig functions are located above the regular trig functions. So see in blue you have inverse sine, inverse cosine, and inverse tangent. And you get to those by pressing the second key and then the corresponding key for the trig function that you want. So for example, if I want to do the inverse sine function, I press second, sine, and I can go ahead and do 1. We close off that, press enter, and notice it gives us 90 degrees. I can also do second cosine, and let's go ahead and do the square root of 2 over 2. So we'll do the square root of 2 divided by 2 and press enter, and you see that we get 45 degrees. So that's how those functions work. Now just note that the answer that you get for these are in line with the values that you get for an inverse trig function. So when you're doing these, you need to double check and make sure that your problem actually reflects these values. If not, and we'll show those in a couple of problems after I do this, you have to do some minor adjusting by adding or subtracting 180 or 360 from these values to get the proper angle for your problem that you're working on. So with that, let's get to our problems. So before I start doing some of these problems, I want to briefly go over a subtle but very important distinction between the two types of problems that you'll see on these. So first of all, if you are given the problem sine, the inverse sine of 0.5 or 1/2, you would immediately know that that could only equal 30 degrees, because the only thing in the inverse sine function that can have a sine of 0.5 is 30 degrees. However, if I give you this problem, the sine of x equals 0.5. Notice the difference here. The inverse sine function has these restrictions on the range where it can only be 30 degrees. However, the sine of x equals 0.5 asks you what angles, plural, have the sine of 0.5. So if you were to do that problem, you would look at something like this. You would say, okay, this is 30 degrees, and this angle also has a sine of 0.5, which is 30 degrees from here. So my angle, my total angle, which is here, would be 180 degrees minus 30 degrees, which equals 150 degrees. So your answer is going to be 30 degrees and 150 degrees. Now, in getting the answer to these problems, we want these angles to be between 0 and 360 degrees, or between 0 and 2 pi. And so that's how these particular problems, where I'm doing a sine of x equals some value, a cosine of x equals some value, or a tangent of x equals some value, I want that angle to be between 0 and 360 degrees, or between 0 and 2 pi. However, if I'm given an inverse sine function, that would be either 30 degrees, or it could also be negative 30 degrees. So it's a bit different in terms of how we represent our answer, since we do restrict our angles between certain ranges. So that being said, let's go ahead and work some of these problems. One of the things we can do is we can actually use our calculators to help us with these. So these types of problems, as you can see, will give us two angles for our solution, because again, it's not really the inverse sine function I'm asking for. I'm asking for all angles that have a sine, in this case, of 0.5. So let's go ahead and try this. So if we plug it into our calculator, the inverse sine function of 0.5, it's going to give us 30 degrees. And that, of course, is one answer, because it's between 0 and 30 degrees. The other answer would be this angle here, which is 30 degrees from the horizontal, and that's going to be 180 minus 30, which equals 150 degrees. So those are our two answers. Here's another similar problem. Again, we plug in our 0.7 into our inverse function in our calculator, and that's going to give us 45.6 degrees. And we can then say, okay, what other angle is going to give us a similar cosine? Well, we know it's going to be this angle down here. Well, we will want to represent that as an angle between 0 and 360. So it's going to be 360 degrees minus 45.6, which equals 314.4 degrees. Again, just to reiterate, we see that this angle and this angle have the same cosine. So in order to get that second angle, we have to subtract 360 from 45.6 degrees, so that it's between 0 and 360. Problem C has a tangent of x equals negative 8. Well, for a negative tangent, we know that's going to be in quadrants 2 and 4. So I go ahead and I punch into my calculator the inverse tangent of negative 8, and that's going to give me negative 82 0.9 degrees. So again, I want my angles to be between 0 and 360 degrees. So if I draw this out, I know that here is my angle is negative 82.9 degrees. So the first thing I'm going to do is go ahead and do a coterminal angle by adding 360. So negative 82.9 degrees plus 360 degrees equals 277.1 degrees. So we can also do this angle. Again, we know that it's in quadrant 2. So right here is our 82.9 degrees from the horizontal. So what we're going to do to get this angle between 0 and 2 pi, we're going to go ahead and subtract 180. So this is going to be 180 degrees minus 82.9 degrees, and that's going to give me 97.1 degrees. So my answers to this problem are going to be 277.1 and 97.1 degrees. Okay, let's try problem D. So problem D has a negative sign. Well, we know that negative signs are going to be either here or here. So that's in quadrant 3 and quadrant 4. So let's go ahead and plug into our calculators the inverse sine of negative 0.8, and that's going to give us negative 53.1 degrees. So of course that negative 53.1 degrees is this angle here. And so in order to get that between 0 and 360, I'm going to go ahead and add 360 plus negative 53.1 degrees, and that comes out to 306.9 degrees. Well, I also want to get my angle in quadrant 3, which is going to be this angle here. And in order to do that, I'm going to go ahead and add 180 degrees plus 53.1 degrees, and that gives me 233.1 degrees. So these are my two answers to this particular problem. So in our next problem, we have the cosine of x equals negative 0.2. So with that, we know that the angles must be in quadrants 2 and quadrants 3. Since the cosine is negative, it's going to be to the left of 0. Let's go ahead and plug this into our calculators. And when we plug that in, we're going to get the angle 101.5. So that's one of our angles, and that's between 0 and 360, which is what we want. So that looks something like this. So if this is 101.5, that leaves us that this angle here must be 78.5. And we're going to also have that same 78.5 down here, which is in our quadrant 3. So our second angle is going to be 180 plus 78.5, and that's going to equal 258.5. And so those are our two answers. 101.5 degrees and 258.5 degrees. Our next problem is the tangent of x equals negative 2.3. Well, that tells us that with a negative tangent, it has to be in quadrants 2 and quadrant 4. So we plug that into our calculator, the inverse tangent of negative 2.3, and that will give us negative 66.5, which of course is right down here. That's our angle here. And now we have to put it into the right format. So it's in quadrant 4, so we're going to add 360 to it. So we'll just do plus 360, and that gives us 293.5 degrees. So that's our first angle. So our next angle, again, we know it's in quadrants 2 and 4. So we're going to go ahead and put this angle here, 66.5 degrees. And to get that in quadrant 2, we'll subtract it from 180. So this winds up being 180 degrees minus 66.5 degrees. And that leaves us with 113.5 degrees. So those are our two answers. So for our next series of problems, we're going to do problems that involve combinations of inverse functions and regular functions. And let's go ahead and see some of these. So in some cases you see where I'm doing an inverse function to a regular function, and you might think, well, these are both reciprocals, so I can just go ahead and cancel these out. So for example, the tangent of the arctangent of negative 5 would equal negative 5. Well, in this case, that does work. However, I would caution you to be very careful with these, because in some cases they will not. So in this example, with our tangent and arctangent, if I go ahead and I do an inverse of tangent of negative 5 in my calculator, I'll get negative 78.69 degrees. I'll then do the tangent of negative 78.69 degrees, and that will give me negative 5. So in this case that works, but again, by doing it like this, you're really guaranteed to get the right answer. And let me show you on the next one where that fails. We're going to do the arc sine of the sine of 5 pi over 3. So it might look obvious that you could just go ahead and do a canceling, and that would equal 5 pi over 3. However, if you do this, that would be incorrect, and here's why. So first of all, the arc sine function is only defined between negative pi over 2 and pi over 2. Well, this is the sine of 5 pi over 3, which is outside of negative pi over 2 and pi over 2. So what we have to do first is actually evaluate the sine of 5 pi over 3, which is negative the square root of 3 over 2. Then we do the arc sine of the negative square root of 3 over 2. And you can do that in your calculator, or sometimes you may have to do it by hand. And that's going to equal negative pi over 3, which falls within the range of negative pi over 2 and positive pi over 2. So this is your answer. For our next problem, we have the inverse cosine of pi. Now notice cosine can only be between negative 1 and 1, so it's kind of a trick question. So this whole thing is actually out of range. So either way you say it, the bottom line is that it doesn't work and you can't do it. So it's either undefined or out of range. Either of those will work. Okay, for our next type of problem, we are doing different functions of different things. And to do that, we have to use right triangle trigonometry to actually calculate that and figure it out. So in this case here, we have the tangent of the arc cosine of 2/3. So notice the cosine is going to be adjacent over hypotenuse. So if this is our angle here, the adjacent angle is going to be 2. The hypotenuse is going to be 3. And so if we just compute our other side, so it's going to be 2 squared plus b squared equals 3 squared. or b equals the square root of 5. So this side's the square root of 5. And they want the tangent of theta, which is going to be opposite over adjacent, which is just going to be the square root of 5 over 2. Again, that's the opposite over adjacent side. And that's our answer. Now, for our next one, we're doing the cosine of the arc sine of negative 3/5. So again, we draw a triangle. Now, notice that our hypotenuse is always going to be positive. The sine is obviously opposite over hypotenuse, so we're going to make our opposite side negative 3. Our hypotenuse will be 5. And we know that this is a 3, 4, 5 triangle, so this has to be 4. And so now we'll just do our cosine. So our cosine of theta is going to be adjacent over hypotenuse, or 4 over 5. Okay, so our final problem in this series is to write each of the following as an algebraic expression in x. So let's first go ahead and do our triangle. So here's our triangle, our right triangle. Here's our angle. And notice that our cosine is going to be 3x over 1, which is just going to be adjacent over hypotenuse. So the adjacent angle here is 3x. Our hypotenuse is 1. And now we have to compute this other side. So that's going to be 3x squared plus b squared equals 1 squared. And so we have 9x squared plus b squared equals 1. B squared equals 1 minus 9x squared, or b equals the square root of 1 minus 9x squared. So we have the square root of 1 minus 9x squared for this side. And now they want the sine. So the sine of theta is simply opposite over hypotenuse, which is just 1 minus 9x squared over 1, which equals the square root of 1 minus 9x squared. And that's our answer. The next one is simply asking for the cotangent. And there the cotangent is going to be adjacent over opposite, which equals 3x over the square root of 1 minus 9x squared. And of course, we have to rationalize our denominator. So it's going to be 3x times the square root of 1 minus 9x squared all over 1 minus 9x squared. And that's it. If you have any questions, I'll be ready for questions when I get back on Monday.